We'll proceed in vector field line integral, but now we'll take vector field in 3D. So that is the idea for the session, that how it would behave if it is 3D. Vector field, vector field calculation when it is in 3D. We have done enough for 2D. Now it's time for 3D. So, what is 3D concept behind the vector field line integral? I mean, we have done for enough for 2D. What we have learned from 2D? If we have done enough for 2D, then what we have learned from 2D? Calculus is science of algebra. Calculus is game of algebra. What is algebra? Algebra is nothing but I have a algebraic equation called x square plus y square equal to 2 square. That is equation of a circle. Okay? Calculus do not rely upon. If I say that I have a equation that is x square plus y square equal to equal to equal to 2 square, if that is the case, then what is then this is algebraic equation, typical. But calculus doesn't work in this fashion. Calculus work with algebra where there is independent component, dependent component. Then what? Okay, if I have a story in 2D, in two dimension only, then certainly there is one dependent component and there is one independent component. If there is a story in 3D, then there is two independent component and one dependent component. Two independent component means x-axis, y-axis, xy plane, and dependent component, that is fx, that is z. Okay, so if I say x square plus y square equal to 2 square, 4, there is circle and it is 3D where x and y being independent component, then we can say it is in where z is 0, where z is 0. In that way, x square plus y square equal to 2 square. But still, if it x square plus y square equal to 2 square, then I cannot take any x and y and it will become 2 square. I can take any x and then y will be calculated based upon the x if it is in z equal to 0. So algebraic equation which has typically one dependent component and multiple independent component, that is a kind of choice for calculus. Calculus thinks about independent component, dependent component. If a programmer or if a mathematician, if he understands the concept of independent component, dependent component, as far as algebra is concerned, then he is cracking the algebra, knowingly, unknowingly. So if I see vector field, if I have a vector field capital F, I have a vector field capital F. What is its line integral in 2D? Line integral always happens in 2D because, mostly, because line is a line. So line is a line which has a surface that is 2D behind it. Okay. So anyway, now consider that I have a vector field capital F and there is a line that is u vector. What is line integral of capital F along capital F along u vector? So what we learned is if I have a vector field and there is a u vector, then vector field component along u, that is effective vector along the u line, that first I have to find, and then it will result in an algebraic equation. That algebraic equation du. If u vector is x-axis I, then if this is vector field, then vector field I component or vector field dot I, then it would come, vector field come in along the x-axis. Then whatever the algebra we are getting, dot product will lead into algebra rather than any vector. Whatever algebra we are getting, okay, if it is a kind of algebra, maybe in x, y, z, whatever it is, algebra dx, algebra equation dx integral. If it is a vector u and if it is vector field f, then f dot u unit vector, it would result in an algebraic equation du is the integral, the way we have dx. If dx is the integration sign, then along any vector it is du. So vector field f, if it is u vector, vector field f dot with u unit vector, this shows that vector field f, effective vector field f along the u vector du. du. If that is the case, then integration sign if I put, that gives me vector field f line integral along u vector. Now break it. Let's break it. So vector field capital F is nothing but f1i plus f2j. Means it has components along I axis, it has component along j axis. F capital F equal to f1i plus f2j. Now if I have a unit vector u can be a straight line, you can be a parabola, you can be anything. If it is a vector, so if it is a parabola or something like that, then it is algebraic vector. If it is algebraic vector, then consider this as any point on the vector, any point on the u line is xi plus yj. Valid. Okay, so I believe I come forward. I was talking about independent component, dependent component. So if I have a circle x square plus y square equal to 2 square, then independent component is x, then y is dependent component. Both I cannot take independent. If I take both as independent, then certainly many places it won't be 2 square. X square plus y square equal to 2 square is not possible. X equal to 2, x equal to 2, y equal to 4. This is my algebraic equation. Certainly it's not possible equal to 2 square. So if x equal to 2, then y has to be 0. If x equal to 1, then y we have to take accordingly. I believe a square root of 3. So y is dependent component, x is independent component. If we say I have a paraboloid, equation is y square plus x square minus z equal to 0 or some constant. Okay, calculus do not believe on this. You have to segregate what is independent and what is dependent. So z equal to x square plus y square. Now it. So x and y two are independent component where z is dependent upon them. Independent means x I can keep any value, y I can keep any value. Y and x they are not dependent upon each other. Being independent, now z is dependent upon x and y. If that is the case, then we can also consider that z is dependent upon only one independent component, that is xy plane. This is the future of the calculus. Independent component has to be only one. If I have four dimensional like density function, where independent components are x, y and z, then I can say the density function has only one independent component, that is x, y, z cube. That's it. X, Y, Z, Q. Okay. Now based upon this independent component, Z is varying. Since it is X, Y, Z, Q, further I can dissociate in Z axis and XY plane. XY plane again I can dissociate into X and Y axis. This is future. But this is how it is. So this is the future of calculus, that independent component should be only one. Either it can be a line, it can be a surface, or it can be cube and whatsoever. This is the way we can proceed in machine learning and artificial intelligence, where the components may be 100 in numbers, not 3, 100 in numbers. So then calculation would be easy. I believe so. Anyway, now let's proceed. So I have vector field capital F, and along any u vector, what is the vector field line integral? Every integration is line integral. By default, if independent component is x only, then vector field line integral is dx along x-axis. If independent component are x-axis and y-axis, that is in 3D we see, then then integration is along xy plane. We also call it dx dy. Okay, if the kind of in 4D where independent component is x, y, and z, then integration is happening along x, y, z cube, that is dx, dy, dz. First, you have to calculate integration with for x dx, set the limit. Then again you have to do integrate with y, set the limit, whatever comes, then you have to integrate with z and whatever comes. We have seen this typically in density functions where we have x, y, z, or in cylindrical coordinate where we have r, theta and z, or in a spherical coordinate where we have r, theta and pi, three components variable. Anyway, but concept is independent component should be only one, not two. Either it can be cube, surface or line, but whatever is available right now, that we will tell. So line integral of vector field capital F along any vector u, capital F dot u unit vector du. If unit vector, if I take along u, then vector field F dot du vector. This is what we have seen. Now vector field F has two components, F1 and F2. If it is 2D, F1i plus F2j, whereas u vector has two components, that is xi plus yj. If it is xi plus yj, and if I do d of xi plus yj, it becomes dxi plus dyj. If that is the situation, it becomes dxi plus dyj, then f1i plus f2j dot dxi plus dyj would result in a kind of algebraic differential equation. So differential equation is f1 dx plus f2 dy capital. If that is the case, for which I have to calculate the integral from first point of the line to the last point of the line. So if I have a line from 0, from 2 0 or 1 0 to 0 2, this is what many times we have seen, 1 0 to 1 0 to 0 2, their integration I have to place 1 0 to 0 2, but this is not something that is common, 1 0 to 2 0. I have to set in some axis. Okay, whatever the differential equation for the algebra for the line integral is f1 dx plus f2 dy. Now it is clear how it came is f dot unit vector of u. If it is u line and there is a f vector's integration, if I want to find along the u vector, there f components along u vector first. That is f dot u unit vector. If I do f component along u vector comes, then that component du I have to integrate from, if this is u vector, then first point and last point, along which I have to calculate the line integral. That is capital F dot u unit vector du. If that is the case, then u unit vector, if I take right side, then it becomes capital F dot du vector. Now, u is a vector, and any point in the vector, if I talk about position vector, then that becomes xi plus yj. So d of xi plus yj results into dxi plus dyj, and here capital F can be modified to f1i plus f2j, where f1 and f2 are its components. So f1i plus f2j dot dxi plus dyj becomes f1 dx plus f2 dy. This has to be understood to any extent. This is now the platform on which we will start running. f1 dx plus f2 dy integration from first point to the last point, begin to end. So if I take a line, if it is x-axis and y-axis, there is a line, interception on x-axis is 1 comma 0, interception on y-axis is 0 comma 2, then the equation now, the equation is integration from 1 comma 0 to 0 comma 2, x dx, sorry, f1 dx plus f2 dy. Now let's do in two dimensional the line integral for a vector field, that is f1 vector field capital F. So line integral means the line is nothing but a semicircle. Semicircle. So equation of semicircle where radius is 1, unit radius. So it starts from minus 1, goes here, and then plus 1. So minus 1 0 to 0 1, and then 1 dot 0. It goes in clockwise direction. Now, as per the differential equation what we have seen, f1 dx plus f2 dy. What is y? X square plus y square equal to 1. Means y is 1 minus x square square root. If y is square root of 1 minus x square, then what is dy? Then dy would come as minus x divided by a square root of 1 minus x square dx. Please substitute there. So it will become f1 dx plus f2 into minus x divided by square root of 1 minus x square dx. Why we did this? Because independent component is only one, that is x, not y. Y is dependent component. So we bring it in x only. So now we have f1 dx plus f2 into minus xy square root of 1 minus x square dx. Actually, we are trying to integrate f1 plus f2 into minus xy square root of 1 minus x square full in bracket dx, where x is from minus 1 to 1. This is the line integral. If I try to solve as a parametric equation where x I'll keep as some variation in t. So consider x is cos t. If x is cos t and x square plus y square equal to 1, then certainly y is sin t. Then only it is 1. So if that is the case, now we will happily replace here f1 dx. If cos t is x, then dx is minus sin t dt. So f1 into minus sin t dt. And that side now y plus y dy. Y dy, if y is sin t, then dy is cos t dt. So f2 dy results in f2 into cos t into dt. So here f1 minus sin t dt, f2 cos t dt, that results in f1, whatever f1 into f1 into minus sine t plus f2 into cos t dt. Now t, be careful when you set t here. If x equal to cos t and x is minus 1 to 1 means t will vary pi. So pi to 0, not 0 to pi to 0. Now I have to integrate from pi to 0. Now consider vector field f is xi plus yj, xi plus yj. So x is cos t. So cos t, now consider this. If this is circle, then inside the du line vector, if I have a position vector of the circle, if this is the semicircle and this is the center, if there is a position vector, then I am calculating capital F dot du. Du of the position vector will be a tangential. Now I have a vector field xi plus yj, that is like radial and tangential, dot will be 0. So answer should be 0 because the vector field is tangential, whereas the kind of du, the line vector is the line what vector what we are taking, that is tangential vector we are taking. Du, not u. F dot u, not f dot du, differentiation of u. So if I take u vector as position vector, then du will be tangential vector. Now capital F is like a position radial vector. Capital vector is like radial and one is tangential. Dot product will be 0. Anyway, let's calculate. F1 minus sine t dt or F1 minus sine t dt plus F2 cos t dt. So F1 x is x. Vector field capital F is xi plus yj. So F1 is x. X is cos t. So cos t into sine t minus cos t sine t dt. That side F2 is y. Xi plus yj. So y, F2 is y. Y is nothing but sine t. Sine t cos t dt. Here minus cos t sine t dt. That side cos t sine t dt. It becomes 0. So at the end, so you can imagine also what's going. So anyway, so what is the idea here? Now let's consider minus yi plus xj. That is the vector field. Then it would result minus y means minus sine t. And here it is minus sine t again. So sine square t dt. And that side xj, xj. So x is cos t. So that would result in cos square t. So sine square t plus cos square t dt. So dt. Now dt integration from pi to 0. So it will result in 0 minus pi minus pi. So it is minus pi is the line integral. What we learned here? We learned that when I have differential equation f1 dx plus f2 dy, then I have to bring it in independent variable. Then, like if independent variable is dx, x, then everything I have to bring in flavor of x1. Or if we are taking parametric vector considering t as independent variable, then I have to take everything in t1. Okay. Anyway, let's proceed in 3D. So now I have differential equation f1 dx plus f2 dy. Now it will change in because vector field is in 3D. So it has three components, f1 I plus f2 j plus f3 k. Similarly, u line vector has three components, that is now xi plus yj plus zk du. It will come as dxi plus dyj plus dzk. Here f1i plus f2j plus f3k. If I do dot product, then f1 dx plus f2 dy plus f3 dz. Now integration from one end to another end. Now it's a clever step to change everything in x1 or in any parametric equation of t. Okay, let's consider that I have a vector field that is capital F. So that is F1, F2, F3. Now I want line integral. Mind it, I'm not talking about surface integral. Line integral in YZ plane, that is y square plus z square equal to 1, that is a circle in YZ plane at x equal to 0. So this is x-axis, this is y-axis, this is z-axis. Then in YZ plane, there is a circle. If there is a circle, equation is y square plus z square equal to 1 at x equal to 0. A different x, yz plane exists. If that is the case, then if x equal to 0, then dx equal to gone. I have f1 dx plus f2 dy plus f3 dz. How many independent components are there? There are two independent components. So typically, integration would happen within xy plane rather than along x-axis only or y-axis only. So the net integration should be dx dy as per the concept of independent and dependent. Since it is a line equation, so we have some leeway, we have some excuses. So if I have a line that is y square plus z square equal to 1 and it is in x equal to 0 plane, if that line is there, then if that line is there, then f1 dx plus f2 dy plus f3 dz dx is gone. Now I have f2 dy plus f3 dz. Now only one independent component is remaining, that is y. So let's remove the dependent, that is z. Now y square plus z square equal to 1 means z equal to square root of 1 minus y square. Then dz equal to minus y by a square root of 1 minus y square. Now our integral becomes f2 dy plus f3 into minus y by a square root of 1 minus y square dy. That results in f2 plus f3 into minus y divided by 1 minus y square root full bracket dy. Now integration y I have to set 1. So this is the way we are trying to tackle 3D in vector field arena, where we are changing everything into single independent variable. Now let's consider that I have a line from 0, 0, 0, that is origin to 2, 3, 4. Along this line, what is the line integral of a vector field capital F? Then it is f1 dx plus f2 dy plus f3 dz. Now, if what is the now I have to draw the vector. Okay, so dx, dy, and dz needs to be calculated. What is dy by dx? If now what is the line? Line is from 0, 0, 0 to 2, 3, 4. There is change in 3 for y. Y changes 0 to 3, then x changes 0 to 2. dy by dx is equal to 3 by 2. dy equal to 3 by 2 dx or y equal to 3 by 2 x. What is dz by dx? That is 4 by 2. Then dz by dx is 4 by 2. Then dz equal to 4 by 2 dx. Then z equal to 4 by 2 x. Now let's place here. f1 dx, nice. f2 dy, dy is 3 by 2 dx. So f2 into 3 by 2 dx. Now z is 4 by 2 dx. So f3 4 by 2 dx. Now if I take all together f1 plus 3 by f1 plus f2 into 3 by 2 plus f3 into 4 by 2 dx. Now set 0 to 2. This is the line integral. Or if I take parametric vector, so consider the f1, the function f is x cube I plus y square j plus zk. This is the equation of vector field capital F. Then this would replace as x to the power 3 dx plus y square then y is nothing but 3 by 2x. So 3 by 2x whole square into 3 by 2 dx plus z dz. Z is 4 by 2x into 4 by 2 dx. So it would result in x to the power 3 dx plus 9 into 3, 27 by 8 dx, 27 by 8 x square dx plus 4 by 2 is 2. So 2 into 2, 4, 4x dx, full in dx, then 0 to 2. What about parametric vector? What about parametric vector? So if I have if I have variation of x, if I take in t, then if I have 0, 0, comma 0, comma 0 to 2, comma 3, comma 4, then variation if x equal to 2t, then y equal to 3t, then z equal to 4t. This is the parametric vector, and then plus through what it is passing through. If it is passing through origin, then origin vector. So that is the offset. So origin vector is 0. So at the end, the parametric equation is 2ti plus 3tj plus 4tk. Now here I have to substitute. I have a vector field f is x to the power 3 or f1 into 2 dt plus f2 into 3 dt plus f3 into 4 dt. Now f1, f2, f3 I have to substitute. Now capital F is x to the power 3i plus y square j, x to the power 3i plus y to the power y square j plus zk. Now here x, where now we have x to the power 3 dx plus y square dy plus zk. Now dx becomes 2 dt, dy becomes 3 dt, and z becomes 4 dt. Now it becomes altogether 2t to the power 3, x I replace with 2t, 2 to the power 3, 2t to the power 3 into 2 dt. Now 3t into square 3 dt, and then 4t into 4 dt. Now everything came as dt. Now calculate the integration, but make sure what the in lower limit and higher limit you put. I want x from 0 to 2. If x equal to 2t, then t is from 0 to 1, because x is twice of t. So now limit is 0 to 1 and 2t into power 3, then 2 dt. That will become 8 into 2, 16 t to the power 3 dt plus 2t square, 4 into 3, 12 t square dt, and then 4t into 4, 16 t dt. This is through parametric. So this is how we solve the kind of line integral in 3D. Okay, make sure that you bring everything into one independent variable, and then you can do. We can do it because after all, it is a line integral. It is not surface integral that we. So this is the kind of, we are ending our vector field line integral. So this is how we do vector field line integral. If we talk about, if I have a vector field and if I try to not write through differential equation, and if I know that vector field is a kind of line path independent, we can try calculating potential function directly from the vector field. So a vector field is y to the power q I plus x to the power 3 xq I plus y square j plus zk. Then what would be its potential function? I can think about some function whose df by small f, df by dx I plus df by dy j plus df by dz, df by dx I plus df by dy j plus df by dz k. If I do like this, then it would result in x cube I plus y square j plus z k. Okay, can we try this? How it will be? I believe if I take uh, okay, if I take 3 by 4 x to the power 4, the differentiation will be 3 by 4 x to the power 4 will be, I mean, 1 by 4 x to the power 4. Then it will become x to the power 3, 4x to the power 3 differentiation. So 1 by 4 x to the power 4 plus 1 by 3 y to the power 3 plus half x square. If this is the potential function, then what is df by dx? That is x to the power 3. What is df by dy? Then it will result in y square. And what is df by dz? Then it will result in z. It is exactly as capital. So this is the potential function. Okay. Now place it there. That is now half x to the power 4 by 4 y to the power 3 by 3 and z to the power 2 by 2. This is the potential function for the vector field. So it looks like it is kind of continuous. Okay. Now if it is continuous, then set the limit, whatever limit comes to your mind. Okay. So that is the kind of scenario. Okay. So I believe we can, whatever comes to your mind. So this is path independent because we found the potential function. So this way also we can calculate the kind of line integral along a line. What is now our chapter of the line in vector field line integral in 3D is over. What about vector field surface integral? If we think about vector field surface integral, then we have to think about two independent components, like vector field capital F along a paraboloid, that is z equal to x square plus y square. Now I cannot take x equal to t and y equal to t because x and y are independent to each other. If it was a line, then I saw the changes in the line. I cannot take 2 points in the paraboloid because if I take 2 points, then it constructs a line, not the parabola. So x and y are independent components. I cannot take both as t. Okay, I cannot take both as t. I can, okay. So now I can go with the differential equation, that is dx, that is f1 dx plus f2 dy plus f3 dz. f1 dx will be intact, f2 dy will be intact. Both are independent components now. f3 dz, this will be broken into x and y, So f1 dx I have to break in a fashion that it will result in dx dy. Green's theorem, curl testing. So f1 by dy, df1 by dy, if I calculate, then f1 dx is equal to df1 by dy dx dy. This is my fundamental. This is not anywhere. Surface integral. Okay. df1 by dy. We will place a disclosure on it. Anyway, we have one new disclosure that is right now at Medium. So meaning.medium.com or medium.com / at the rate of MINHINC. This is our channel name. Just kick out the space in between min in continuous meaning. So medium.com / at the rate of meaning. You can see our the latest disclosure on machine learning, where we have in the cosine distance, if I take two vector in machine learning, then two vector distance as far as cosine distance is concerned, not as a Euclidean distance, then how much is what would be the calculus so that we can have minimum inertia of a data set. So that we have calculated as far as calculating the average new mean is concerned. So it is, I believe, how it works. That is the last to last. So that is the section, I believe, section number 12, how it works, or section number 11. There, the what is the minimum inertia of a data set when we take the distance measure as cosine distance. There we have done partial derivative. So that can be seen here. Anyway, now if this is the case, then now f1 dx plus f2 dy plus f3 dz. If two independent components are there, x and y, then we have to respect the independent component. That is the concept. If we want to respect the independent component, then df1 by dy, f1 dx, if I do df1 by dy, then it will result in dx dy. Again, df2 by dx would result in dx dy. This is xy plane. Now we are integrating along xy plane. Now f3 dz. Now dz, z, we have z equal to x square plus y square as far as paraboloid is concerned. Lest we have to do differentiation of the z along xy plane. So df3 by dx dy, df3 by dx dy, that would result, or f3, if I dz, then dz somehow I have to change into dx dy. So dz I have to change it into, so z, if I place and if I do differentiation, that will be single differentiation. Okay, either it will be in dx or dy. So full f3 dz I have to change into some algebraic equation dx dy. Now full will come into dx dy and some algebraic equation that I have to integrate in xy plane. 2 points, one begin point, end point, where begin point is in xy plane and end point is in xy plane. If we are successful in doing this, then this will be commencement, this will be begin of a new era where we are thinking about integration along surface. Then we can proceed integration along a cube that is not available right now. Okay, Green's theorem, that is df2 by dx minus df1 by dy, and integrating dx dy and placing the double limit, that is the one sign that Mr. Green is giving, that if we can do surface integration, but still that is only f1 and f2. At the end it is 2d only. So dx and dy is not required that way. But he gives a hint that we can proceed towards the single independent component. Either it is x or xy plane or xyz cube or something like that. If we grow in this fashion, then for multi-dimensional machine learning data sample, data set vector, document vector, we can tackle quickly. Anyway, so I have provided one way to proceed in surface integral for a vector field. If it is f1 dx, f2 dy, f3 dz, then f1 df1 by dy dx dy, df2 by dx dy, and f3 dz I have to break into dx dy and whatever f3 comes in. Add everything and integrate with the dx dy, means along surface plane xy. Do the double integration and you are done. So someone, I believe, if people are kind of listening and if people are saying it, if someone is kind of can proceed in this, then let's calculate a vector field f, that is x cube I plus y square j plus zk, that is a vector field along a paraboloid, that is a surface, z equal to x square plus y square, and then any kind of any point, that is 0, 0, 0 to some 0, 0, 0, 3 points, 2, 2, 3, 4, whatever it is. Surface integral vector field. Anyway, so we will conclude the vector field where we started vector field with kind of a simple algebraic equation calculus. Then we started proceeding towards path independent vector field and we calculated a potential function from capital F only, and if it exists, then we saw path independent, or the closed loop line integral is 0, again path independent, or curl testing df2 d2 df2 by dx minus df1 by dy if it is 0, then it is again path independent. If it is path independent, then f capital F vector dot du vector, u vector, anything I can take because it is path independent. Or directly anyway we are getting the potential function. I have to set the limit. Then so that is, then we saw the green theorem. If it is not path independent, then we have to calculate the full integral. But if it is in a closed region, if it is the line integral, line is a closed loop, then it creates a region. So I can integrate over the region x axis and y axis, and the integral is d2 df2 by dx minus df1 by dy dx dy. This is what Mr. Green is saying. If you do this, then for dependent also you can do the line integral through the surface region integration. Okay, and then now we can have curl testing d2 df2 by dx minus df1 by dx dy, and that is along k vector. For 3D also curl vector is available, that is df3 by dy minus df2 by dz I vector, like this df2 by dx minus df1 by dy k vector, and then df1 by dz minus df3 by dx, then j vector. That is a curl vector in 3D that we will see later. And then now 3D line, 3D vector field line integral. What is homework now? Can we proceed for the surface integral for a vector field path I have shown for a paraboloid? That is the questionnaire. Z equal to x square plus y square, or z square plus y square plus x square plus y square plus z square equal to radius square, that is sphere, or z equal to square root of x square plus y square, that is a cone. So this kind of shape can we calculate surface integral for a vector field f, that is f1i plus f2j plus f3k, or x3 x cube I plus y square j plus zk, anything I can take as vector. So that we will see.